So with the summer arrival and with the climate change, the number of fire is increasing from year to year. So those fire has a big impact in the natural ecosystems. And the change can affect plant succession and the ability of the ecosystem to return to its native state. So our objective here is to quantify, or before studying the behavior of those ecosystems, and try to quantify the amount of fluxes of the different gases. The study zone is belonging to the municipal term of Las Majadas, that situated in the Cuenca mountain range in Castilla-La Mancha region. The mean average temperature is from 10.3 degrees with an annual rainfall of 983 millimeters, and it's concerned a burned area of Spanish black pine, or Pinus nigra salzmani, or Pino laricio in Spanish. The fire took place in July 2009 with a devastated area of 1,800 hectares. Beside the principal species, there is a sublayer formed principally from Juniperus communis, Juniperus oxycedris, Crataegus monogyna, and Baxus sempervirens, associated to a subshrub layer dominated principally by Genista scorpius and the lipid gender-like Thymus, Lavandula, and Salvia. The experimental site was chosen on the basis of a map of severity obtained with the spectral analysis imagery of Landsat image, using the corrected reflectances in the band 4 and band 7 of Landsat, and using the difference between the normalized burn ratio index between the post-fire and pre-fire image. The result is a classified image of severity, and within those class we choose two: the low severity with when the fire has burned just the sublayer vegetation and small trees, against the high severity where there is no standing trees. So we put two eddy covariance systems with 6 meter and 27 meter height, respectively. The system consists in an open path infrared gas analyzer to measure CO2 and H2O densities, and the three-dimensional sonic anemometer, in this case is the Young 81000, to measure the three components, the three wind components, and the sonic temperature. So how does it work? So the theory behind this technique is that the airflow is a horizontal stream of eddies from small to big size. Each eddy rotates in the 3 dimensions with a quantity of, or a density of CO2 and H2O. And when it arrives to the sensor over the canopy, they are measured, and with the vertical wind components, the flux is calculated. And we can, with this technique, what we really measure is the net ecosystem exchange, which is the difference between ecosystem respiration and the gross primary productivity, which is photosynthesis. The obtained result are the following. So in the 30 minutes flux evolution, we see that from spring to autumn, the difference between the unburned and burned zone, the unburned zone is where the low severity is increasing, passing from spring to autumn. This difference can be due to that the herbaceous cover lost the capacity to assimilate CO2 and enters in a to assimilate CO2 when passing the growing season. In the case of water vapor fluxes, we see that in spring and autumn the difference are small, but in the summer flux are bigger in the unburned zone and smaller in the burned zone. This is because can be due to the rapid depletion of soil water content in the burned zone, and vegetation in this case enters rapidly in a hydric stress. When we see the daily variation, we can deduce that the unburned zone can act like a sink, absorbing CO2 from the atmosphere because the net ecosystem exchange is under zero all over the studied period. Against the burned zone that's acting like a source of CO2. By doing a separation of the net ecosystem exchange into ecosystem respiration and gross primary productivity, we can see that the difference is due more to the GPP than the respiration that is less affected. So in the case of water vapor, the key of the difference is done to the summer when we make a difference into seasonal variation. And like this, we can conclude that the EDE covariance system allows a good comparison between the burned and unburned zone, and we can quantify the amounts of carbon uptaken or released to the atmosphere. In this case, in the burned zone, during the studied period, there is 120 gram carbon per square meter released to the atmosphere. And in the unburned zone, 219 gram absorbed from it. And the amount of evapotranspiration was 310 millimeter and 214 millimeter respectively in the unburned and the unburned zone. And that is all. Thanks.